Have you ever pondered the repercussions of going back in time and accidentally erasing your existence? Now that's a question to stir the gray matter, isn't it? Let's dive into the belly of the beast known as the grandfather paradox. Imagine this. You've built a time machine, you decide to test it out, you set the dial to, let's say, 70 years ago. You pop out in the past and there's your young, sprightly grandfather, oblivious to the fact that his future grandchild is standing right before him. But here's where things get tricky. You, for some unfathomable reason, decide to alter the timeline. You off your grandfather. Grim, I know, but stick with me. So your grandfather is gone long before your parents were even a twinkle in his eye. This means your parents were never born. Consequently, you were never born. But if you were never born, then who traveled back in time to eliminate dear old granddad? Thus, we find ourselves in the clutches of the grandfather paradox, a logical dilemma that has become a staple in the realm of time travel. This paradox is a compelling argument against the possibility of time travel. It's a logical loop that defies our understanding of causality and continuity. Quite a conundrum, isn't it? But hold on to your hats because we've only just scratched the surface. What if your actions in the past were not only unavoidable but necessary for your present existence? Welcome to the Predestination Paradox, a mind-bending concept that will have you questioning the very nature of free will. Picture this. You invent a time machine and decide to travel back in time. You meet a stranger who inspires you to become an inventor. Years later, you realize that stranger was you. You've become the very inspiration that led you to your present existence. This is the essence of the predestination paradox, a loop with no clear beginning or end. Now you might be thinking, this sounds like something out of a science fiction novel. And well, you wouldn't be wrong. The world of pop culture has given us some fantastic examples of the predestination paradox. One that might tickle your fancy is Harry Potter and the Prisoner of Azkaban. Remember when Harry conjures a Patronus to save himself and Sirius Black from the Dementors? Later he realizes that he was the one who conjured the Patronus in the first place. A classic predestination paradox. In the end, the predestination paradox presents a fascinating question. Are we truly masters of our fate, or are we simply prisoners of our own actions, trapped in a loop of our own making? It's a question that continues to baffle even the brightest minds. So we are prisoners of our own actions, trapped in a loop of our own making. What happens when an object or information has no discernible origin? Enter the Bootstrap Paradox, a time-twisting quandary that traps objects or information in an infinite cause-effect loop. Imagine for a moment a book. This is no ordinary book, but a tome of knowledge sent back in time. The author in the future scribes it using an older version as a reference. So the question is, who wrote the book originally, the author or the book itself? A similar scenario occurs in popular culture, specifically in the British sci-fi series Doctor Who. Remember the episode Blink? A transcript of a conversation is sent back in time and the Doctor reads from it in the present. But the transcript only exists because it was read out in the first place. This is a classic example of the Bootstrap Paradox. So where does this leave us? Well, in a bit of a pickle, to be honest. The Bootstrap Paradox is a veritable chicken and egg scenario, but with a temporal twist. It's a headache-inducing puzzle that leaves us questioning the very nature of causality and origin. Yet isn't it fascinating? It's like a never-ending waltz, where the dancers are time and matter, locked in an eternal sequence of steps without a clear beginning or end. A timeless conundrum indeed. But as they say, time waits for no one. Can you imagine a universe where time isn't linear? Now that's a head-scratcher, isn't it? Welcome to the realm of closed time-like curves, a concept that would make even H.G. Wells' head spin. In the world of theoretical physics, we're often asked to suspend our belief in the ordinary. Closed time-like curves, or CTCs, are no exception. These are solutions to Einstein's field equations in his general theory of relativity that allow for time travel. Yes, you heard it right, time travel. Here's the gist. CTCs are paths through space-time that, if traversed, could take you back to the exact moment you started your journey. It's like going on a cosmic merry-go-round where every ride takes you back to square one, no matter how far you've gone. Now, if you're picturing Doctor Who's TARDIS or the DeLorean from Back to the Future, hold your horses. The existence of CTCs doesn't necessarily mean we can start packing for a trip to the Jurassic era or the distant future. CTCs are still purely theoretical, and the universe might have safety measures to prevent such time-bending shenanigans. But isn't it fascinating to ponder the possibilities? Time travel has been a staple of science fiction for centuries, and CTCs bring us one step closer to understanding how it might actually work. Who knew physics could take us on such a wild ride? Whether it's through a wormhole, a DeLorean, or a closed time-like curve, the journey through time is sure to be a thrilling adventure. What if every decision you made spawned an entirely new universe? Now that's a question to make your head spin, isn't it? This is the heart of the many worlds interpretation of quantum mechanics, a theory that suggests all possible alternate histories and futures are not just figments of our imagination, but are as real as the universe we inhabit. Let's break it down. Imagine you're at a cafe deciding between a cappuccino and an espresso. According to the many worlds interpretation, the moment you make your choice, the universe splits in two. In one universe, you're relishing that cappuccino, and in another, you're sipping an espresso. This interpretation was first proposed by physicist Hugh Everett in the mid-20th century, and it's been stirring debates ever since. It's like a cosmic game of what if that never ends. It's a concept so vast, so mind-boggling, it's been a favorite among science fiction writers and filmmakers. Ever seen the movie Back to the Future? Well, imagine Marty McFly's actions creating not just one, but an infinite number of timelines. Or take the Avengers Endgame. Every snap of the Infinity Gauntlet, every choice made by our heroes could be spawning countless new universes. It's a lot to take in, isn't it? But we're just getting started. Could the laws of physics actually prevent time travel? It's a question that's been posed by many a curious mind. The chronology protection conjecture, a hypothesis proposed by none other than Stephen Hawking, tackles this very issue. Hawking, the renowned physicist and cosmologist, suggested that the laws of physics might actually forbid time travel to prevent any possible paradoxes. Imagine that. The universe, in its infinite wisdom, may have set up safeguards to stop us from mucking about with the delicate fabric of space-time. The chronology protection conjecture hinges on quantum physics and how it interacts with the concept of time travel. According to Hawking, any time machine would generate a massive amount of energy, enough to destroy itself before any actual time travel could occur. Now you might be thinking, well, that's a bit of a downer. But hold on to your TARDIS, because there's still hope. This is, after all, a conjecture, an educated guess, not a proven law. The physics community remains divided on this issue. Some agree with Hawking's view, while others believe there's still a chance we might find a loophole in the laws of physics. So what's the bottom line here? Well, if the chronology protection conjecture holds true, we might have to toss our dreams of time-hopping adventures into the bin. But if it doesn't, who knows what incredible journeys await us in the future? Or should I say, in the past? Perhaps time is more resilient than we thought. Could the universe be self-correcting, preventing paradoxes from occurring? Now let's delve into the Novikov self-consistency principle, the fascinating hypothesis that puts forth the idea that the timeline is inherently self-consistent and makes paradoxes an impossibility. Imagine, if you will, a time traveler journeying back into the past with the intent to alter a significant event. According to the Novikov principle, no matter how hard they try, they simply can't succeed. Why, you ask? Well, the principle posits that any event that could cause a paradox has a zero probability of happening. It's a bit like trying to break the speed of light. Physics just says no. In effect, the Novikov principle suggests that the universe has a built-in paradox prevention system. If you've ever wondered why Marty McFly's meddling in Back to the Future didn't rip apart the fabric of space-time, this principle might just be your answer. So let's say you're a time traveler and you decide to pull a Terminator and take out your own grandfather. According to Novikov, you'd be thwarted by the cosmos itself. Perhaps you'd miss every shot, or maybe your gun would jam. In any case, the universe would conspire to maintain its own consistency. The Novikov self-consistency principle is a fascinating idea that could provide a solution to the time travel paradoxes that have puzzled scientists and sci-fi fans alike. It suggests that the universe, in all its vastness and complexity, has its own checks and balances. So, even if we could time travel, the universe has its own fail-safes. Intriguing, isn't it? How has popular culture tackled the brain-bending concept of time travel? Let's dive into the world of fiction, where time travel has been a captivating theme for decades. Consider the Back to the Future series. Here, the protagonist Marty McFly accidentally alters his parents' past, nearly erasing his own existence. This is a prime example of the grandfather paradox, where changing events in the past leads to impossibilities in the present. Then there's Star Trek, a franchise that has navigated the space-time continuum with finesse. Its many episodes have explored the Predestination Paradox, where characters are caught in time loops, their actions in the past ensuring the future they know. Doctor Who, the British sci-fi classic, often grapples with the Bootstrap Paradox. The Doctor himself explains it as an object or piece of information sent back in time becoming trapped within an infinite cause-effect loop, in which the item no longer has a discernible point of origin. And let's not forget Harry Potter and the Prisoner of Azkaban, where the use of a time turner aligns with the Novikov self-consistency principle. The principle suggests that if an event could cause a paradox, the probability of that event is zero. So while these stories may seem far-fetched, they are grounded in real theoretical concepts, making them not only entertaining but also intellectually stimulating. And we thought our reality was complicated. What does the future hold for the study of time travel? Peering into the crystal ball of scientific curiosity, the future of time travel research shimmers with possibility. Quantum mechanics, that enigmatic branch of physics, is at the forefront of this exploration. As we delve into the subatomic world, we stumble upon quantum entanglement, a phenomenon that might just be the key to unlocking the secrets of time travel. Imagine, if you will, a pair of entangled particles. Despite being separated by vast distances, a change in one particle instantly affects its twin. Could this instantaneous communication be a form of time travel at a quantum level? Only time and rigorous research will tell. Then there's the field of particle physics, where researchers are investigating tachyons, theoretical particles that move faster than light. If these elusive particles exist and can be harnessed, they could potentially enable us to send information back in time. And let's not forget the role of quantum computing, a technology that could simulate time travel scenarios with unprecedented accuracy. By running complex models and simulations, these supercomputers might provide us with a deeper understanding of temporal mechanics. As we step into the future, the study of time travel continues to push the boundaries of our understanding, bringing us one step closer to answering the question, can we truly master time? The future, it seems, is full of possibilities. Should we even tamper with time if given the chance? This is where we tread into the realm of ethics, a dimension as complex and convoluted as time itself. Time travel, in theory, is a Pandora's box of endless possibilities and potential misuses. Imagine, if you will, a future where time travel is as commonplace as catching a bus. Could we trust every Tom, Dick, and Harry with the ability to alter the course of history? A single misplaced step in the past could potentially bring about the butterfly effect, leading to unforeseen and possibly catastrophic changes in the present. And then, there's the question of moral responsibility. If one could travel back in time and prevent a tragedy, would they be obliged to do so, or would doing so infringe upon the natural flow of time, causing more harm than good? Consider the Time Lord's dilemma in Doctor Who, where he must often choose between interfering and letting history take its course. Or the lessons from the time turner in Harry Potter, where even the most well-intentioned alterations can have unintended consequences. These ethical quandaries remind us that time travel isn't just about the mechanics or the paradoxes, it's about the profound responsibility that comes with wielding such power. Perhaps the most important question isn't how to time travel, but whether we should. Because, as Uncle Ben once told Peter Parker, with great power comes great responsibility. And in the case of time travel, the power and the responsibility could not be greater.